Hello guys, welcome to Academicus. So this is my first video on complete design of RCC building. So this RCC building, G+6 RCC building, that there will be a series of lectures. You have to follow all those videos so that you can completely get the design procedure and design stages of your RCC buildings. So there are many stages, but the first and the foremost and the most important stage is the preliminary stage, where we just make a design basis report. Design basis report is nothing but uh, it is a complete setup of assumptions, complete setup of your input details, complete setup of your design hypothesis, and complete setup of your design problem. So design basis report consists of basically the loadings, the reference of all the codes, the input details like your grade of concrete, your grade of steel, the grade of which type of wall you are using. Either you are using a brick wall or you are using a C4X block, or whichever material you are using. So those things are mentioned in the design basis report. The reference of those things are mentioned in the design basis report. So the first stage is you have to prepare, like if you are ready with, even if you are not ready with the architectural drawing plan of your building, then also just this design basis report is the basis of assumptions. Like you need to, if you are assuming something, that you should have to mention in the design basis report. So design basis report is irrespective of your architectural layout. Just you need to confirm whether how much story you are just proposing your design, like G plus 3, 4, 5, 6 or 15 or 20, 50, whatever floor you are proposing, or you can just mention the height of the building or and the plan dimension. Otherwise, this is basically your design basis report is basically your loading concentration, your load combinations, for what load combinations you're designing your buildings, your codal provisions, if there is any exception codal provisions, those codal provisions, your reference code. So just design basis report, I'm just explaining this. So the first is the location, where exactly your project is located. So location should be mentioned. General, the following are the proposed building. If your building is a residential building or a commercial building. So if it is a commercial building, you just change it to a residential commercial buildings. In our case, we are designing a residential buildings. We are designing ground plus 6-story RCC building of this. This is the plan dimension. We can change it later on when I'll just doing the modeling and I'll be designing. I'll just change, either if I need to change, I'll change this, or I'll keep it as the same. Next comes your codes, design codes. So we have loading codes, which I have already uploaded many videos on design the code, the load as per IS 875. So IS 875 part 1 dead loads, IS 875 part 2 like imposed load, that is live load. 875 part 3 is wind load. 875 part 5 is special loads and load combination. Part 4 is your 875 part 4 is your this snow load. So we are, I'm just assuming as the location is to be Mumbai. So Mumbai we don't have a snowfall, so we are not just mentioning the snow load code. Then comes your seismic provisions for buildings. So for seismic load, as per Indian standard IS 1893-2002. So on IS 1893 we have uploaded both the static design procedure of seismic load calculation and dynamics, and also a video where you can just find the suitability, which method, like which either dynamic or static is applicable to your structures. So you can just refer those videos and you'll get a brief idea of this seismic load IS 1893-2002. IS 1392-1993 is the ductile detailing. So IS 13920 will explain you whether your structure need to be need to have a ductile detailing, or you can go as per the detailing of IS 456-2000 normal detailing. So for this also IS 13920-1993, I have already uploaded a video on ductile reason why I'm coming with this design of G+6 building late is because I need to cover all these parts previously, so that you will be getting clear idea regarding what we are going to design. So we have already uploaded 13 ISO ductile detailing based on 13920, 1893 and this 875. So next is your building code requirements. So I have uploaded a video on beam design, column design, slab design, RCC staircase design. We have so many videos based on IS 456 2000 is a plain and reinforced concrete code of practice. SP16 is the draft code. SP34 is also the handbook of concrete reinforcement and detailing. IS 13370 is the design of, like, in a project, in a building projects, you will be coming up with, other than buildings, which all structures are coming, like you'll be having a water tank underground or overhead or resting on a ground. So as per IS 3370, we have to design the storage of liquid structures. So I have uploaded video on this IS 3370, so you can refer those videos. So these codes need to be very specific, where whichever code you are using. Other than these, if you are using any code, you have to specify those codes, like materials, like reinforcement. I'm not we have generally just need the grade of concrete, the grade of steel, so we are not just putting all those codes. You can elaborate, you can put, or if you want to add, you can put the individual code of your materials, your concrete, your steel, so you can do that. Formwork also you can add whichever code you are using, but these are the basics, these are the major codes: load, seismic, and your building design. So this was regarding the code. So the code does not include your soil report, your foundation design. So for that you have to attach the soil investigation report. This that will be prepared by the Geotechnical Limited, that is the soil investigation agency. So we will get the soil report from that soil investigation reports. So if you are doing the soil investigation, if your consultancy is doing soil investigation, then you can just attach the soil investigation with your DBR, but keep it as a separate document. Please don't include soil investigation report in the DBR. Only you can just mention the soil bearing capacity or the recommendations as per the geotechnical investigation. So you can just put on the recommendations, whether you have a pile foundation, whether you have a raft foundation, where you have a pile draft foundation, or your, in case if you have a pile foundation, whether you're using end bearing piles or you are using your friction pile. So these things you can put, but please try to keep soil investigation as a separate document and your this DBR as a separate documents. Now comes to the material part. So whichever material you are using, just here cast in situ, your grade of concrete, cubic strength, concrete grade, and short term EC modulus of elasticity, Poisson's ratio, your coefficient of thermal expansions, reinforcement grade. So as IS 1786, like I've written 1786 here, we can include that here also. So FE 500 or FI 415, whichever grade you are using. So this was regarding the grade of steel, grade of concretes, and your design codes. Now let us get into the loads which we are taking for our projects. So for first floor we are using a imposed dead load, floor finish 150 kg per meter square, partition load 150 kg per meter square, superimposed dead load. There are some, these are the superimposed dead load on your first floor. The wall load of 230 mm, if you are using 230 mm wall, then that wall load will be acting as a dead load. If you are using 150 mm thick walls in your internal column beams, so you can use these thickness as the for calculation of dead load. The architectural plan will generally help you to get the thickness of these walls. The walls which are directly resting on slabs are considered as lightweight materials, such as, so these as I said earlier, this either you can use a C4X block or you can use brick. So based on this, like C4X blocks are generally very lightweight, so we are using here, in case you want your design to be very heavy, you just take the weight of your the weight of brick, because the density of brick is more. This is a project, this DBR is from actual executed project, so we used C4X block to just optimize the design, because the dead load based on this will be very less. So with a density of 0.8 ton per meter cube and applied as equivalent UDL. So this that the dead load of wall will be applied as UDL. Live load 1000 kg per meter square superimposed. So now staircase floor finish, total superimposed dead load, live loads on staircase. So these loads like toilet rooms, roof terrace, overhead tank as per actual. So these loads will be based on this dead load, and live load will be based on, as I've discussed, that we have already uploaded video on this IS 875 part 1, and part 2 will be dealing with your dead load, and live load will be getting those, like if you have a residential buildings, what is the dead load, what is the live load on your toilet, staircase, your uh, living room. So based on the occupancy, you have the live load, and dead load will be as per your material specification. Like if you are using a brick wall, so the unit weight of brick, the unit weight of RCC, the unit weight of C4X. So based on these, I'll be calculating. This is the DVR just to explain the preliminary step of RCC building design. So when we'll be doing the problem, we will be explaining how which all materials, we'll be just opening those codal provisions, and we'll be just looking into that. So this was your live load and dead load. So wind load as per IS 875 part 3. So this building which I have been proposing is in Mumbai. So Mumbai, the wind speed is, basic wind speed is 44 ms. Probability factors I've taken 1, terrain category 3, building class B, dimension less greater than 20. So based on the dimension and height, the your building class is decided. Topography factor K3 1, terrain factor, height factor K2 from table. So these we will be actually doing these calculations. So if you want to get a brief idea regarding wind load calculation, I've already uploaded a wind load video on IS8 using IS 875 part 3. Seismic loads. So Mumbai comes under zone 3. Zone factor is 0.61. Importance factor. So as per your building, your importance factor you can decide as per code, or if you want your structure to be more to have a more strength, you can just increase important factor. You can increase, you cannot decrease the important factor, but you can increase as per your priority. If you want to give your building more importance, you can just increase this factor, importance factor. Type of lateral system, ordinary moment resisting frame. We are proposing an ordinary moment resisting frame. Response reduction factor as per table 3. Soil class as per your soil investigation report. Height of the building, so I'm proposing a 21.6 meter height above ground. Base dimension, as I said, will be keeping this same base dimension, 16.25 meter by 16.89. Fundamental natural time, this is the formula for calculation of time period. SA by G varies with TA. So this, regarding this, I have already uploaded the video seismic weight calculation using both static as well as dynamic method. Regarding the seismic load is calculated. So seismic load is calculated based on your dead load, but some part of your imposed load, that is live load, is also considered while calculating your seismic load. IS 1893 suggests 50% of imposed load and 25% of imposed load as per the codal provision. So in our case it is 50%, but I'll be explaining both where 50% is required and 25% is required. So this is the formula for base shear calculation based on IS 1893. These are the deflection limits. So these will be you need to just mention these deflection limits as per the code. So we are not getting into general deflection limits. So you remember, if you're using software, then these will be taken care by the software, because software, the codon provisions are already there. So if any codal provisions are already there in the software. So if it violates any of these deflection limits, it will show that your member is failing, your member is critical under this category. Now it comes to the load combination. So we have already done loadings. So now the important part which we have not covered, we just coming to the load combination. So load combination is your dead load, and comes to your live load, then wind coming around. Wind can come along both the directions, like your x, if your software you have that symmetry x, y and z. So the plan area, long and transverse direction, both direction wind will blow, and negative as well as positive. Similarly, earthquake is a similar load, like it is a horizontal load, so it can take place in both the direction, negative as well as positive, and both longitudinal and lateral directions. So these are the wind x direction wind load, y direction wind load. So these y direction, this after x direction x positive, then x negative, y positive, y negative. Seismic load, seismic x positive, positive, negative, and these are the eccentricity in 5% eccentricity y direction. So load combinations. So for load combinations, we need to consider two categories. Like we have load combinations different for your foundations and different for your structure design. For foundation, the difference between the load combination of foundation and structure is only one thing, that these coefficients, these factor of safety for foundation, it is considered as ones, like 1 times of dead plus live load. Whereas if you see the structure design, 1.5 dead load, 1.5 dead, you can see the difference. While the structure is designed for factored load, whereas foundation is designed for unfactored load. Now why this unfactored load is considered for foundation? Because while designing the foundation, this is not the final load. On this, the reaction obtained from this load combination will be again multiplied with the factor of safety for your foundation design. Meanwhile, in your structure design, this is your final design load combination with factor of safety. So hope this is clear, like why we are using 1 in foundation design and 1.5 in your structure design, because for structure this is the final load, whereas foundation, based on this load, there are more factor of safety applied during foundation design. So these are the load combinations. So when we are designing these load combinations, basically your design load combination: dead load, dead plus live, dead load plus earthquake, dead load earthquake, positive x, negative x, earthquake positive x, positive y, positive. This is eccentricity, based on your eccentricity on y direction. So these combinations, as per your specification, as per the code, you can just apply. One important thing regarding load combination you need to take care is that wind load and earthquake load never act together. Like if you are having dead load plus live load plus wind load, then you need not to consider earthquake load. Or if you are having earthquake load, dead load and live load, then there is no wind load. That means dead, live, earthquake and wind are not acting together. Only a combination of dead, live, earthquake, or dead, live or wind will act on your structure. So hope this first video on your design of RCC building is clear. This is the basic step for designing of RCC building. So in the next video we'll be doing a modeling part, then after that we'll be doing the loading part, then after loading analysis part, then once the analysis is done, we'll be doing the design part. So now after this video, after DBR, your first stage DBR is ready. Now you need the architectural layout. So I'll be discussing about the architectural layout in the next video. Based on the architectural layout, you'll be placing your columns and beams. So next video we'll be talking about first the architectural layout. Once architectural layout is finalized, we'll be modeling. So architectural and modeling will be covered in a single video lecture. Then we'll be going for loading. So loading will take much time. So loading actually requires time. So I'll be covering the loading lecture video in single loading and load combination in single video. So then comes the foundation. So foundation then comes loading of analysis and design. Then I'll be explaining the detailing of your RCC, detailing of your beam, column and slab. Will be staircase. I'm not going to cover in this part because we have already uploaded a staircase design, so you can refer those videos, because I'm just focusing on the superstructure and foundation design. So staircase, water tank already uploaded. So in the DBR I've just discussed about the staircase and water tank in order to just have a clarity like which all things we do have in our projects, like in a design project of a building. So now after this your superstructure is done, we'll be going to design the foundation and explaining the foundation design as well as detailing. So once we are done, so to prepare all these videos we definitely require time, so please have patience and please keep watching our videos and please keep sharing our videos. We will be definitely completing this series of G+6 video lectures. You just need to have some patience. So I'll be coming up with more videos, series of videos like this part will be, I think it will be covered in 10-11 lectures. So please have patience, please keep sharing our videos, and please press the bell icon so that you won't miss any notifications regarding our videos. Thank you, have a nice day, take care and goodbye.